Hello. Today we're going to be going over 1.3 complex numbers. But before we begin, we're going to do a couple problems as a warm up. Okay. So if you have a graphing calculator, go ahead and take that out. If you don't have a graphing calculator, you can go to www.decimals.com. That's what I'm going to be using today. So I want you first to graph this and this equation. And we're going to see where the solutions are. Now, the solutions are where the parabola crosses the x-axis. The solutions are also known as the roots or the zeros or the x-intercepts, okay? So I'm going to take this equation right here and this equation, and I'm going to put them into decimals, okay? So I already have 1 and 2 here. So I'm going to go ahead and click on the first example, okay? Notice we have a parabola. Now, when you come and graph it on decimals, you click on the parabola, and it's going to give you some key points: the zeros or the solutions, the y-intercept, and also the vertex down here. So right now, we are only looking at the x-intercepts, the solutions, the zeros, the roots, right? So that would be this point right here, -1, 0, and this point right here, 5, 0. So these are my solutions, or also known as roots, x-intercepts, and zeros. Okay, so I'm going to write this for my solution set right here. -1, 0, and 5, 0. And I'm going to do the same thing for this problem right here. So I go back to decimals. I'm going to unhighlight this problem. I'm going to highlight this problem. Now I get a new graph. What's really cool about decimals is that you can kind of zoom in and you could really see where the points are. So again, you want to click on the parabola itself, and it's going to give you key points: the y-intercept, the vertex, but right now we're looking for the x-intercepts, the solutions, the roots, the zeros. So I click on it, and I get my two solutions right there: -2, 0, and -1, 0. So I'm going to write that in: -2, 0, and -1, 0. Okay. We'll work on these two problems on the next video. So on this problem, on these two problems, we're actually looking for the factors, right? So the factors it's gonna look something similar to this, and then from there we can actually get the solutions, right? So we should be able to see something happen, a progression. So I'm gonna work on this problem so you guys could try your luck on this one. All right. So this one, don't mind the n. The n is just a variable. It works just like x. It could be w, it could be z, it could be anything, right? So right now, don't worry about it too much. If you see problems like that in your book, don't worry about it too much, okay? So right here, I notice it does not say equal 0. Notice over here it says equal 0, equal 0. That's what we want. We want it to say equal 0. So how do we get this problem? How do you get this to equal 0? Well, we have to subtract 5. But what you do to one side, you must do to the other. And notice I subtract 5 from the 15, not the 7n or the n squared, because this is just a number by itself. So now I have n squared plus 7n, and 15 minus 5 gives me 10. That's a 10. So now what I want to do is I want to look for two numbers that when I multiply them, give me 10, but when I add them, give me 7. So do any numbers come to mind? Right off the bat, I think of 10 and 1. 10 and 1, if I add them, does not give me 7. However, there's another set, 5 and 2. 5 times 2 gives me 10, but when I add 5 plus 2, that gives me 7. So I get my factors. So I could have n plus 5 and n plus 2 as my factors. And if I want to know the solutions, I take it one step further, and I already see a pattern happening. If it was x plus 2, it becomes a -2. If it's plus 1, it becomes a -1. If it's a -5, it becomes a +5. If it's a +1, it becomes a -1. So my solutions here would just be -5, 0, 2, comma, 0. So what I want you to try to do on your own is I want you to try to do this problem on your own. Okay? Good luck. Okay, so now let's get into the notes for today. 1.3, complex numbers notes. So right now what I want you guys to do is I want you to, you're going to pause the video, right? And I want you to Google what is the square root of -1, right? So what happens when we have a negative under the square root? We've always been taught that that's a big no-no, but as our advanced math continues, we're finding ways to work around stuff like this. So right now, I want you guys to Google what is the square root of -1. Okay, you're gonna pause this video. You're gonna do it. By the time I start talking again, you should already have an answer. Okay, so the square root of a -1 should give you I, a new symbol. We call this an imaginary unit. Okay. So if we have I, what would I squared be? Okay, so we know that square root of -1 equals I. And we want to find I squared. Well, I squared would be just I times I, or we could say square root of -1 times square root of -1. And we know that when you multiply the same thing, it's like saying -1, square root of -1 squared. So that means this and this kind of balance each other out. And we're just left with I squared being -1. So that means we have square root of -1. We have -1. So then what is I to the third? Well, we already know I squared is just -1 times I. So that means it's -1 times I. So what's -1 times a square root of -1? Negative square root of -1. And what would I to the fourth be? Well, I to the fourth would be just I squared times I squared, which means -1 times -1, which gives us +1. Whoops. I don't know why I wrote I. +1. Okay, so I want you to see if you see a pattern happening. What's going to happen with 5, 6, 7, and 8? What is the pattern that's going to be transparent, right? And then after that, can you come up with a way to figure out what I to the 47th is? I to the 99 is? Okay, I'm going to let you figure that out right now. You guys go ahead and pause this video. Try to figure out I to the 5th, 6th, 7th, and 8th, and see if you can figure out a pattern. Okay? Ready? Set? Go. Okay, so we're coming back. So I to the 5th, 6th, 7th, and 8th should be what? I to the 5th should be I. I to the 6th, I squared. I to the 7th, I to the 3rd. And then I8 is I to the 4th. So they kind of just repeat. It becomes like a little cycle. So how would you guys get I to the 47 or I to the 99? What would you do? So how do we figure out I to the 47, right? So what we're going to do is we know it's the cycle repeats every 4. So that means we're going to have 47 divided by 4. So this, in this case, should be 11.75. Well, we know anything right here, this 4 is key, right? So that means this is going to be our whole number. So had this been 48, 48 divided by 4 is 12, it would land perfect right here. But we don't. We have a 75. So what do you think that is? Well, what is 75 cents? It's 3/4, right? 3/4. So that means this one's going to be 0.75. 2 is going to be 0.50. I by itself is just 1, so 0.25. So 47 divided by 4 is 11.75. So this would be equivalent to I of the third, which is just negative square root of -1. So how would you get 99? Do that on your own. Hello. So this is a little reminder sheet that I like to use, right? I call it the imaginary cycle. And it kind of gives me the flow of things, right? Some of you guys might see this later on. When we get into 3D graphing or maybe using GeoGebra, we could kind of see this a little bit better, especially graphing parabolas that actually use the imaginary unit plane. So this is almost the 2D version, but it's kind of hard to see 2D. It's best to see it on a 3D graphic. All right, so this is something good to have and store and just kind of look at. Right, I just realized that I'm waving my mouse, but you guys can't see what I'm talking about. So what I meant is right here in this figure, this is kind of like a 2D version of the imaginary plane. However, you only get the imaginary plane in kind of like a 3D graph, what we will see in GeoGebra. Okay, but this is the breakdown that I kind of helped me remember whenever they ask me what is I to the 446, right? This was the key for me, right? When I was doing my undergrads and my studies, that helped me out a lot. So I just kind of wanted to share that with you guys. So yeah. So what is the complex number? Right. So we're talking about these imaginary units. You saw this little cycle. You figured out I to the 148, right? So how do we know what a complex number is? Well, a complex number comes into play whenever we have a real part and we have an imaginary part. So when does this happen? Well, it happens when you have stuff like this. Now we see this quite a bit when we're dealing with the quadratic formula, right? The negative b plus or minus the square root of 4 b squared minus 4ac divided by 2a, right? We see that quite a bit. Well, and we see it when we start breaking it down. So before it was like, oh, there's a negative inside, no real solutions, and there we stopped, right? But now that we're in a more advanced math, we have now the imaginary plane, right? The imaginary units that we can deal with. So we still need to break this down. So right here, this fraction right here could be broken down into two separate fractions. 9 divided by 6, we could reduce it 3 halves. But now we have this negative 144 under the square root. So just like before, we would factor out a -1. So we could get a positive 144, which then turns into 12. 12 divided by 6 is just 2. But then we're left with the square root of -1, which we already know what this is. This is just I. So what is I over 1? Well, I over 1 is just I. So now what we could do is we could actually work out some of these problems. I will do the odds and you're going to do the evens, okay? So right here, we could break this up into two factors. We have negative 16, that will be positive 16 times a -1. We already know what the square root of -1 is. It's just I. And the square root of 16 is just 4. So our answer is just 4i. Now, whenever we have something that's similar, what we can do is we know that that is just saying this squared. And the square and the square root balance each other out, leaving us with 7. Oops, nope, sorry, -7. Now, number 5 is similar to what we just saw, the example we saw. So let's break it up into two fractions. And we know that this side, which would be considered the real part of the complex number, is just -2. Okay. we're going to take out a -1, just like we did up here with the 16. So this is now going to become square root of 128 over 4, and we're just going to put the I on the outside because we're going to take out, we're going to break up this to 128 times -1. Okay, that -1 under the square root is just I. So now, what is the square root of -128? So what I'm going to do is I'm going to get 128 and I'm going to break it up. I get 2 times 64. Hey, and I know what 64 is. 64 is 8 times 8. So that means I could take out a pair of 8s. So this becomes -2 plus 8 square root. The 2 stays on the inside. The I over 4. 8 over 4 is just 2. Square root of 2. And we have an I. Now, what would be I to the 15th? Well, that goes back to what we were doing before. Divided by 4. And we're going to get 3.75. And 0.75 meant that it was going to be I to the 3rd. And does anybody remember I to the 3rd? L, which is negative square root of -1. Now, another way you guys could probably see problems dealing with complex numbers is that when you have two sets of complex numbers, such as this set and this set, and you're either adding them, subtracting them, or you're actually multiplying or dividing them, right? So in most cases, you're going to see add, subtract, and multiply. So we're going to go over a couple examples. I know you could already see the steps, but they're there. And the I, you're just kind of dealing with it very similar to that of a variable, right? So we treat it like if it was X, like if it was Y, like it's Z. So we're going to add all the numbers with all the numbers and all the I's with all the I's. So if you notice, I kind of rearranged stuff. So I have the 3 and the -2 together. And then I have the -4 and the 6i together. So I can kind of see my imaginary part and my real part, okay? So this would be this one right here. So 3 minus 2 is 1. 6i minus 4i is 2i, right? And if we're subtracting it, the only thing is to remember is we have this negative right here in front of the parentheses, so that goes to each one. So if you notice, this 6 becomes a -6. This -7i becomes a positive 7i. So 3i and 7i is 10i. -4 minus 6, -10. And when we're multiplying, same concept, right? We do the, some people call it the moon method or the FOIL method. I just call it distribution, right? We distribute, right? Here's the key thing. We already know what I squared is. I squared equals to -1. You guys got to remember to, once you multiply it out, you got to include that, because then this -12 is not just -12i. It's actually -12. I mean, sorry, not -12i squared. It's -12 times -1, which becomes a positive 12, which then we could add it to the 6, which we get 18. Okay, so just be very cognizant of that. Okay, so when you multiply the i's and you get an I squared, remember that this square is actually -1. And because of that -1, it changes at 25. And sometimes the i's are gonna just disappear, like this one right here, because we got 30i and -30i, so they just disappear, right? They get subtracted from each other, and then the I squared becomes -1. And then so we get just a number, but when we're dealing with complex numbers, we might need to write it like this, plus 0 i's, those 0 imaginary numbers.